Hope everyone's blood is pumping now. So I want to first and foremost thank you all for being here. I know we have quite the variety of individuals joining us, so we're going to jump right into the presentation. If at any point you need anything, again, don't hesitate to reach out to our team here. So without further delay, let's jump in. So today's presentation, if you hadn't guessed it, will be on robotic soldering. This presentation was designed to really navigate new users into the world of robotic soldering and also educate existing users into the new era or the next generation of robotic soldering solutions. So I'll start with a little bit about myself. I don't like to dwell on it too long. There's a version of a younger me there. 12 years of experience. I joined PROMATION USA back in 2010. Co-founded Panda Robotics in 2019. And of course, my specialized area of expertise is in robotic soldering and soldering. But I do have additional expertise in laser marking, collaborative robots, robotic screw driving and dispensing, as well as material handling. So we'll do a quick cap on what we're going to be talking about today. We'll start with ideal applications and common trends that we see. You know, what sort of applications are ideal candidates for robotic soldering? What are we seeing as trends that manufacturers are looking for? Automation. We'll talk about reskilling, reallocation of internal labor workforce. As humans become more and more difficult to hire or find quality candidates, we want to touch on reskilling factors. We'll, of course, do an introduction to robotic soldering. What is it? We'll go into robotic soldering materials and also touch on heating technology for hot iron robotic soldering, different solder feeder types, and types of soldering robots. Then in the latter portion of today's discussion, we'll look at most popular and best-selling solutions. Why are they most popular? Why are they best sellers? Into peripheral robot technology, or what I kind of call the goodies for robotic soldering systems. We'll touch on dynamic vision alignment and essentially a robot selection method. So this is a conversation I have with a variety of clients about how do we steer towards the proper robot solution. Questions you should ask yourself about what's going to be a negotiable or a non-negotiable to me about my robotic solution. We'll touch on product fixturing and tooling, and then our philosophy on letting applications ultimately drive the robotic solution, and then, of course, the next generation of soldering robots. So let's start by just looking at ideal applications. If you know, this isn't all the applications we've done, but if you happen to find yourself doing these applications in a manual process, these are great candidates that we see quite often that lend themselves well to this sort of technology. So first off, about 97% of what we do in our robotics lab happen to be wire attach and battery attach, which makes sense because if you think about it, wires and batteries don't really lend themselves well to mass free flow techniques. Insulation jackets can melt, batteries have some crucial temperature thresholds to be considered. And so if you're doing wire attach or battery attach, those would be great candidates to immediately look at for this sort of technology. We'll talk about high volume and through-hole applications being great candidates as well. And then we also do a lot of edge mount connectors, RF technology, piezo sensors, and certainly much more. So this is just kind of an introductory highlight reel of applications that we find are great candidates for robotic soldering, but ultimately there can be a variety of others. So let's talk about high volume versus high mix. Generally speaking, soldering robots may not be ideal for high mix environments. However, there are exceptions to the rule. And that general rule is that high mix is going to be best served when the robot head configuration, the soldering iron, the tip being used, the wire output kit, and the diameter of the solder wire being used can be standardized for a variety of applications. So when do robots make sense for high mix? Well, first off, if we require high performance and high quality soldering, that would be pretty indicative for robotic soldering, as well as if process data. Humans, just as great solderers as they can be, don't provide any process data or traceability. And lastly, if you're a client that has a high quality robot programmer available, mated with a flexible robot platform, that can be a great resource for you to create and maintain soldering programs rather quickly, getting the project up off the ground. So let's just talk about some key points for implementation of robotic soldering. Ultimately, soldering robots will provide a better management of existing labor workforce. They will improve quality and consistency and remove humans from a rather toxic work environment. So we certainly want to talk about safety improvements. Now, I do love this photo. If anyone has done a bit of hand soldering, they can tell that clearly the operator is not holding the soldering iron in the right place. So we certainly want to create a safer environment for our operators. And of course, that leads to improved cost of operation. You know, with robotics, they're very consistent, and so as such, we'll have a better determination rate of what is my solder tip consumption, what is my alloy consumption, and that will ultimately lead to a better regimented supplies ordering, lean out manufacturing, and removal of waste for manufacturing operations. About it, robotic soldering, because we're pulling from a solder spool and adding, it's an additive solder process as opposed to a subtractive, where we're pulling from a mass tank or removal from a pot, if you will. Now, there are, of course, situations and conditions that lend themselves well to manual soldering. So let's start by identifying what are hand solderers great at. Well, first off, humans are extremely dexterous, right? They have better dexterity than robots out there, and their ability to adapt and adjust their soldering approach on the fly is a really great resource of humans. So when variability in the process can't be limited, for example, like this photo on the presentation here, I have a small jumper wire being installed. The time to fixture and programming this application may take longer. So clients should consider the time it takes to create a program and develop tooling versus if it's a small batch run, just manually soldering it. As with any technology, there are limitations. So in some cases, robotic soldering just can't get the job done because it's too difficult to automate it. So consider that as well. And product fixturing for robots can also be prohibitive. So while we do some unique things and we have the ability to automate the soldering process, we also want to look at product fixturing because it really goes hand in hand with the automation aspect. We had a client that had a great application for robotic soldering, and they built this beautiful fixture, but they over-engineered it to the point where I said, wow, it's really holding the part, but you're not allowing my robot to get in there and get the soldering done. So want to pay special attention to the product fixturing as well. And then lastly, we want to look at the timeliness to load and unload product fixtures is rather counterproductive. If your application and your product fixture is just difficult to load, and it takes longer than it would to manually solder it, perhaps not an ideal candidate for robotic soldering. So some general notes regarding robotic soldering. Even if robotic soldering yields defects, manufacturers should weigh the defect rate versus the throughput of the machine. If the output rate greatly increases, it is possible to still benefit from robotic soldering with nominal rework. I tell this story, PROMATION had gone out and did a study with a Wisconsin-based corporation, and they were exploring robotic soldering. We offered them a demo system. And what we found through the data was that based upon their processing, they still saw a nominal amount of rework. And it was kind of a bittersweet moment for us because we came back and we said, where are you at? Would you like to, bring this technology in-house? And the answer was quite simple. The answer was no, we don't need a robot. And when pressured why, the response was, well, while we still had rework, the production was so greatly improved that we actually ran all of our parts for a year within 30 days. So again, kind of a bittersweet moment. So I always encourage people to look at production throughput as a great asset in terms of increasing productivity. And of course, our philosophy is there's no sense in making a lot of bad parts, obviously. We want to make sure that every part coming off the system is a quality part, and that's obviously where we benchmark the process for. And then I often ask clients, does your ability to produce more parts lead to your ability to sell more goods? And sometimes the answer is no, but often the answer is yes. So I'll call it a labor pool that is shrinking or becoming more difficult to find skilled operators. Sometimes the ability to produce more parts ultimately leads to the greater ability to sell. Now, we always say we want to keep your best hand solderers. They're great resources for you, and we want to look at reskilling the existing workforce. So again, the philosophy being promote employees to robot managers, right? Robots should be an opportunity to promote employees to new roles, not diminish the roles of employees. And that really coincides with the example given here. If my ability is to produce more parts, obviously I'm going to take that labor that was hand soldering and reallocate them to the back end operation because I'm making more. I now need to ship and package more, right? So we want to look at our workforce as kind of fluid in the aspect of how we're utilizing it. All right, so let's take a look into robotic soldering. Again, what is soldering? Soldering can be defined as the joining of parental substrates through the use of creating a strong intermetallic bond. Parental substrates, or two materials, are heated to an elevated temperature, and a third material, often referred to as a filler material of a lower, lesser melt point, is introduced to complete the bonding between the two parental substrates, resulting in electrical conduit. So as such, soldering is a time and temperature relationship. Now, people come to us for automation all the time, and I often like to just simply remind people that in order to properly form an intermetallic bond, the laws of physics suggest you need approximately 2 seconds. Now, there are some minimal exceptions to the rule when we start talking about creating chemical reactions and using lasers and very optimized materials. But in general, when we're talking about hot iron robotic soldering or even dispensing and reflow of solder paste, you're going to need about 2 seconds to properly form that bond. So we have the alloy part down. So let's look at flux. Is it a friend? Is it a foe? What is flux? So I've defined that in its simplest form, flux is an activating agent or a cleaning agent that is designed to remove organic contaminants and oxidization from the parental substrates to allow that bonding process to occur. And I use this great photo here of these. If you've ever seen SC Johnson's scrubbing bubble commercial, it's a really great analogy that I always use mentally. They have this really dirty bathtub, and this cleaning product is used, and these little scrubbing bubbles go around, and all of a sudden it's sparkly clean. That's really a great analogy for what the flux is doing in our soldering process. It's removing oxidization, fingerprints, sneezes, any foreign contaminants to allow that bonding to take place. So I often refer to flux as our friend. However, depending upon the application, it should be noted that non-activated flux, or in some cases residual flux, can be problematic for device performance and longevity. Flux classifications do range from a no clean up to water soluble or acidic. So there is a whole scale of minimal activity versus extreme activity. I'm also going to say a disclaimer here. Flux is a big topic, perhaps too much for today, but I will provide some general rules for robotic soldering and things for you to think about. If you're hand soldering today and you go out to your production floor, chances are if you pulled a solder spool off your line, you're going to notice that the flux core percentage ranges typically from about a 1.2 to 2.4%. Now, our recommendations, and I'll explain this graph behind me in just a moment, our recommendations for robotic soldering is going to be about a 2.4 to a 4.7%. Okay, and this guarantees a little bit more activity throughout the process. So let me explain this graph for a moment. When people come to us, and this kind of goes to the last point on the screen, how do we solder faster, right? I can't change the laws of physics, but are there things I can do to actually create a more productive robot and actually solder faster? So there's a few things we need to understand. First off, we know that soldering is a time and temperature relationship. So if I want to solder faster, I have to increase heat transfer. So what do? Well, I increase the temperature of my soldering station. However, it's important to note that flux burn-off is linear. So if this line represents here, this lower line, represents a nominal temperature and a 1.2 to 2.2% flux core content, we have a pretty nice process window here. So by using the same flux percentage, this red line here indicates a 1.2 to 2% as well. If I increase my temperature, you can see that my process window is severely shortened, right? So I'm not getting the activity and the time I need to still form that bond. However, by this greater piece of the puzzle, this outlying line here, actually shows increase the flux core and increase the temperature, I'm actually reopening my process window. So again, in short, that's the reason why we want to increase flux core percentage if at all possible. So again, how do we solder faster with a robot? Well, of course, we increase soldering temperature. Now, there are other solutions, such as the introduction of preheat, and preheat There are a variety of different methods for applying preheat, such as infrared, convectional, or heated nitrogen. But we also want to make sure that we improve and increase the process window or activation window as well by using an increased flux core percentage. Lastly, in order to increase heat transfer, we can look at utilizing a larger tip. Obviously, this would be more thermal mass or more thermal load. And if that can't be done, one of the things that we do is if we have to use a little bit smaller tip, the best way to increase the thermal capacity of the tip is actually by adding a pre-tinning step. So if you think about a small tip, the more solder I add, the more thermal capacity it also holds. So when I make contact with the parental substrates, I'm driving more heat, more surface contact. So solder wire manufacturers are finally on board. This is great news for us. Most solder wire manufacturers now offer automation-specific alloy compositions, and these can include precision wound spools, low spatter, and low residue solutions. And we still find that SAC 305 and tin lead here in the US and North America, I should say, are still the most types of common alloys being used, with a quick runner-up by SM100 or 100% tin. Now, of course, liquid flux is always recommended when available and when we can use it. But an increased flux core percentage in the solder wire does deliver better and more consistent results. Now, I throw this in here as well for optimized materials because we can't forget about the materials that we're joining. Now, there's IPC world, and then as I like to call it, there's the real world. Now, IPC, if you've ever been to IPC school, they go through the how to create a bond, and you're cleaning with an IPA or an alcohol to actually clean the substrates for bonding. However, I'll be honest, when I go out in the real world, chances that clients are cleaning their boards as an added step prior to soldering is, I'll be honest and transparent, slim to none. So again, I digress. By looking at an increased flux core percentage, we're allowed to remove a few more foreign contaminants and still create a strong bonding process. I also thought this was a little interesting as well. I've noticed that some solder wire manufacturers also increase the inner core diameter on their solder spools. And if you think about wire being wrapped around a spool, the outer exterior of that wire is actually stretched as opposed to the inside. So as you get closer and closer to exhausting your solder spool, when you unspool it, we can get little kinks in it. So by increasing the diameter, we're going to get a slightly fewer kinks. And we'll also touch upon some peripheral technology that can help with that, but just something to note. Now, of course, in the optimized materials realm, we also want to look at solder tips and feed tubes. Obviously, they should be optimized for your soldering process. We also want to consider our automated solder tip cleaning method, right? The purpose is to clean and not introduce new contaminants. We want to reduce the contaminants that are on the tip and in the soldering area. If we're using nitrogen for lead-free applications, it should also be ultra pure. It should be at a minimum of 99.9%. And my general recommendation is to also use heated nitrogen, as an ambient temperature nitrogen flowing across the joint could be solidifying while we're still trying to put materials into a liquidous state. Solder wire diameters should be specified to maximize control through the soldering software and the programmer inputs. So we talk about, if I'm in high mix, how do I, still maintain a great visibility for robotic soldering? The idea in one aspect is to standardize as much as possible, but we also have to be realistic that if I'm standardizing my alloy diameter or the size of the wire, that at some point it may not make sense because I'm going to be pulse feeding or inputting a 1 millimeter extension of material, and I may still have too much. So in this case, we want to reduce the diameter, allowing us a little bit more control over the in and out feeds through our robotic system. And of course, fume extraction, tubes and filters should be assigned a PM or a maintenance schedule. Again, our whole idea here is to automate, to improve safety, and so obviously airborne contaminants are equally important. Bear with me, we'll get through this. We'll get a little nitty-gritty, but I promise we'll come out the other side. So there are a variety of different heating technologies available, ranging from perhaps most common induction, eddy current heating systems, and convectional hot air or hot nitrogen. And of course, there are more. Let's look at a hot iron system in terms of wattage and temperature, because I think it's important to understand what's going on here. In short, wattage, or your power supply, where you're setting your temperature, is the ability to replace a detection of lost temperature, right? It's the oomph behind the electrical current providing the temperature that's been lost at the tip. The temperature, of course, can be defined as what our desired set temperature is. Now, the temperature feedback loop is actually a relationship between the sensor position located in the solder tip and its proximity to the soldering area relative to the wattage of the iron. So, again, the sensor position is critical as the closer the sensor is to the soldering area, the sooner I can detect a loss of temperature. By utilizing a higher wattage power supply, I'm actually to replace that loss of temperature much quicker. So ideally, in a ideal solution, we want to be able to detect very quickly and also have the wattage of the power supply replenish that loss of temperature very quickly. So again, the temperature feedback loop will be this relationship in a circular fashion. So an eddy current heating system. The heating element utilizes a special induction coil, right? So when this coil is flooded with a high frequency AC magnetic field is generated. The magnetic beam travels through a magnetized rod or sensor to generate an induction current. This current changes the density of the magnetic field and generates heat. The heating current has a thermal effect that allows the tip to heat quickly and maintain temperature as shown in this chart. The result is an excellent temperature control throughout the soldering process. This process is also known as resistance heating, joule heating, or ohmic heating. Next up, we have induction heating. Now, an important feature about induction heating is the process of generating heat actually occurs in the object itself. So it's not provided by an external heat source such as an eddy current hot iron solution. While this is used in many industrial processes, I like to just kind of hit home with this and say, if you've ever seen a cooktop, that would be very similar to induction style heating, where we're generating heat within your cookware, not necessarily the surface contact area, right? All right, we made it. Hopefully things will get a little bit more fun from here. So let's talk about soldering feeding technology. There are a variety of them out there, and so I've kind of defined some key points for you to understand to better educate yourself on what's going to be the ideal fit for you. Key points of exploration include the solder feeder mounting type, solder wire perforation technology, when it might be necessary, what is it, and changeover requirements by the user. So most common feeding technologies mounted near the robot head should maintain a total feed length of 500 millimeters or less. Now, I say this because I go out to these expos and it's neat that we have industrial robots and cobots with solder feeders on them, but when the feed tube is almost a meter long or greater than 3 feet, what happens is as that head goes up and down and rotates around, we can actually get a pistoning effect of material through the feed tube, which leads to non-volumetric indexing of material. So whenever possible, we do want to reduce the total feed traverse distance or travel distance as much as possible. The highest performing solder feeders, by contrast, will be what we call an underhead mount with a total feed distance of 250 millimeters or less. So in this case, the entire solder feeder is located underneath the robot head and the material itself actually moves up and down with the robot head. Again, there are some outliers here, but generally speaking, solder wire feeders are designed to handle a variety of diameters ranging from about a 0.3 millimeter up to a 1.2 millimeter. So let's get into perforation technology. What is it, right? There are a variety of different solder wire perforation technologies available. Now, we spoke about flux, right? We're using a flux cord wire. The flux is the activating or cleaning agent is being provided with the material we're introducing. And as great as flux is, it's also flammable, right? So we spoke about as I increase my temperature, if you've ever done a bit of hand soldering and introduced wire too quickly with the iron too hot, we get what I call the fireworks display. A lot of flux outgassing and spatter. So what do we do to solder faster and still maintain quality control? Well, we introduce a solder wire perforation technology. So solder wire perforation is the process of cutting into the wire to expose the inner flux core, and this allows the gases created during the soldering process to escape more effectively and more efficiently. Solder wire perforation, known as drilling, actually runs the wire through a serrated set of gears and drills holes into the wire. There are also what we call V-score or blade systems that I want you to imagine much like a razor blade or a pizza wheel. As a wire goes through, we actually score the side of the wire. And there are some differences that we've noticed in which technology that can help you decide which technology might be best for you. So let's take one step back, because as great as solder wire perforation technology is, it's important to know that solder wire perforation does in fact weaken the wire. So if we're doing a lot of forward feeding and backward feeding, we can get what I like to call the soft serve effect in the feeder, where all of a sudden we start spooling wire up at the top. So let's help identify and prepare you for ultimately making the best decision for your technology. So regardless, again, of which technology you use, we are essentially weakening the wire. However, what we found is that drilling gears that are cutting holes into the wire work best on solder wire diameters of about 0.8 millimeters up to about a 1.2. Now our V-score systems, since we offer both, are found best to work on wire diameters ranging from about a 0.5 millimeters up to a 0.8 or no 32 inch for those of you that deal with standard. If the solder wire is less than or equal to a 0.5, you really have the option to go with a standard gnarled gear system, as we find that any real perforation below that point weakens the wire a little bit too much. So while we can do it, unless you're not going to be retracting wire at all, it can weaken the wire a little bit too much. So we just want to be aware of that. It's also important to know that solder wire perforations do cut to a specific depth within the solder wire. If I go from a large diameter to a small diameter, the actual center point is a little bit different. So these feeders are less flexible in handling a variety of different solder wire diameters, as the cutting mechanisms or perforation mechanisms must be changed. So if you're looking for additional flexibility or you're in a high changeover environment, perhaps a spring-loaded gnarled gear system will be more ideal because it's less parts to change out and you're still getting a very high quality solder feeding system. So let's do our technology roundup on solder feeding solutions. So key points, again, include to try and reduce the total feed distance as much as possible to increase process stability. Solder wire perforation is ideal for faster soldering, but does limit the speed of changeover because it's diameter specific. Solder wire perforation method and type depends on the solder wire diameter being used and the composition of alloy. And we always want to try to size the solder feeder to maximize flexibility for the robot programmer, but also offer the largest available flux percentage to the process. We have a variety of robots on display here at PROMATION USA today. So let's identify some different robotic solutions, right? Let's start out with, tabletop. We'll go over the cantilever gantry solutions. We'll just discuss our inline solutions and rotary table solutions, as well as 6-axis robots, which are becoming increasingly popular with collaborative robots, and then ultimately custom solutions, which are, again, custom tailored to specific applications. So let's start with perhaps the most traditional thought when we think of a soldering robot or tabletop systems, right? And there are pros and cons with each of these types. Initially, one of the pros would be that it's a small form factor, right? It's affordable, traditionally safe by design, as we're utilizing a moving plate type. So we load the product on, it hovers under the head, the robot does the job, and then it's ejected forward. So no heating elements actually coming out towards the operator. And again, these are great for batch type processing. However, as some of the cons to be considered might be, comparatively speaking, they can offer a smaller working area. And as great of a benefit in terms of safety a moving plate type can be, it should also be considered a potential for consideration as a weight limitation. So if we do have any heavy products, perhaps a moving plate type is not ideal for you. Also, if we are doing long wires, how we fixture those wires, we don't want to obviously lose anything in transit. So if you're doing small parts or wires, something to be considered with moving plate types. And then also, in terms of adding on additional accessories or what we call peripheral technologies, some technology must reside within the working area of the robot. So if you want multiple different types of cleaning technology, we're going to somewhat further reduce that total working area. So again, just something to be considered when you're sizing up your robot. Now, cantilever robots, by contrast, offer larger working areas. And essentially as a result, they're more flexible. The product does remain stationary through the process. So on these style solutions, we load a product into the work cell, the robot hovers from the rear of the work cell, does the soldering job, and then moves back. Now, as such, we need a more complete solution, right? Because the heating element and feeding gears are actually moving towards the operator. We typically, as with all the cantilever gantries we have here, integrate them with a safety curtain or some sort of safety system. But again, no limit to product weight, right? The cons, however, again, are that the moving head motion does move towards the operator, so they're certainly less safe without a safety enclosure. Now, because they're traditionally larger, they're comparatively more expensive as well. And if you're tight on floor space, something to be considered, because with the larger robot, we are going to consume a little bit more floor space. Now, I mentioned this as a disclaimer yesterday with yesterday's discussion. There are smaller cantilever robots available that offer a better price point. They're a smaller form factor. You just, again, have to kind of take notice as to and balance what is most important to you. And then, of course, we have inline robotics, right? Inline or conveyorized. There's certainly less human intervention involved because we're not loading and unloading a batch-style system. We're doing this autonomously through the use of an upstream and downstream conveyor. And as such, they can be faster, right? We're not waiting on an operator or dealing with any operator fatigue throughout the day. They can be integrated into an SMT line, or I like to call the online-offline solution, because if you think about wires being put into a board or batteries, perhaps it's being done manually by a human anyway. So we normally see these batch-style lines where they have an in-feed conveyor, an inline soldering solution, and then a out-feed conveyor. And of course, they can offer traceability. So if data traceability is a key feature for you, perhaps an inline solution will be ideal in your consideration. Of course, again, some of the positives can be outweighed as a con. It is inline and conveyorized, right? So some clients prefer not to have an inline or conveyorized solution. They are comparatively, again, more expensive as there's more technology going on with them. And then we also want to look at, again, small parts and long wires, because as we transit product, there's always some potential risk for jostling of parts or parts to be lost. So we want to consider that with our inline solutions. Rotary table robots. This is basically, for those of you that maybe have no experience in this realm, this will be very much like a lazy Susan, right? So we load a product on, it indexes to a first station, indexes to the next, so on and so forth. So some of the pros of these systems is that if we're doing an application where we have small joints and large joints on the same application, we have the ability to configure multiple robot heads with different solder tip sizes, different wire diameter sizes. In some cases, albeit very minimal, even different alloy comps, right? So the idea that we can configure multiple heads on a standard solution can be a great benefit. They are, of course, faster as we're moving through an assembly process, and again, leading to a progressive assembly of the product. And then, of course, they're completely customizable. Now, it should be noted as some of the considerations or cons here that they will ultimately consume some more floor space because they're larger. We have more robots being packed into a form factor. They're more expensive because, generally speaking, they're very customized, and they can be more challenging to set up because as opposed to setting up one robot head, maybe setting up multiple processes and developing multiple programs at once. So just some good information for your consideration. Of course, while they've been around for a while, we see new introductions into the 6-axis robot worlds. Some great pros of 6-axis robots is that they can achieve different angles of approach. So with the majority, if not all, of the soldering robots on the market today, the feeder and the soldering iron relationship is fixed. Now you can manually adjust with, getting in there and detensioning a screw, but nearly, if not all of them, are a fixed position that you need to manually change over. Cobots offer a new realm in terms of doing different approaches and different angles of approach. Also, a pro might be for a company, a very large company that is using, for example, let's say a collaborative robot or a 6-axis robot in other areas of their building. There can be a similar robot programming language. So it may benefit you to not have to learn something new or do something that's familiar. So the standardization across multiple production processes can be seen as a pro. Also, they generally feature a higher payload capacity. So again, we're not necessarily moving product, You can configure more on the end effector, and so that might be a benefit to you as well. And lastly, we have architectural soldering. So if you're a client doing RF shield technology where we may have a like a dipole or something with a hat to be able to get up underneath there and nearly solder from what I'd call the bottom side, 6-axis robots can be great for that, again, if products can't be flipped or moved. Of course, one thing to be considered are the solder feed tube lengths. We just want to be aware that our end effector and our robot is capable of handling the weight of your solder feeder. They are going to be more expensive. Collaborative robots have a variety of sensors in them, and then can be more challenging to set up and tune, right? Because it's kind of a one size fits all. There's going to be quite a bit of program and software writing to make sure that your robot is performing the way you need it to be and efficiently. And then lastly, we have custom robots, right? The pros of these systems is that they're generally geared towards high volume with dedicated product and an optimized form factor. So certainly they're high performance in that regard. Now this solution was a solution we designed for a client in Mexico where we have an operator on the front side loading wire assemblies. They run through a very basic cantilever system. It's got dual heads on it. It's soldering 2 products at a time, and then it's being unloaded on the back end, right? So again, cons is that it's a little bit more expensive to sometimes get that customization factor out. Probably the biggest con here is that they're really not flexible, right? So unless you have a dedicated product or a project for this, it's not really going to be easily changed over to do a variety of applications. So again, just rounding out our single axes, dual axes, 3, 4, 5, and 6 different robot types. So on all of these solutions, we'll feature true volumetric indexing of material, a superior temperature feedback loop with controlled temperature, and again, a regimented preheat, a reflow time, a solder introduction. So we have single axis robots, which I know we have here. It's a basic up-down system. Great when you have a high rate of employee turnover and are looking to just get training costs out and set someone down that may be inexperienced. We have dual axis robots, which are basically going to feature an up, down, and a left to right. 3-axis machines will basically have an up, down, left, right, and front to back. And the 4th axis is actually going to be all of those plus a motorized head rotation, right? So 360 degrees rotation. 4 and 5-axis systems are very similar. The only difference is here is that we have a single plate versus a dual alternating slide. So the idea behind 5-axis solutions is that while one is in process, an operator can be unloading and reloading, and then it switches, right? So we get this more progressive assembly and utilization out of the operator. And then, of course, lastly, our 6-axis robots, like your collaborative robots or industrial robot arms. Which is really a perfect lead into what are the most popular and best-selling robot models to date. So we'll be taking a look at really the most popular and best-selling robot we've had for a while now, our 4-axis tabletop soldering robot. And I have one actually right here to my right. These are great for first, I think I might have lost my mic. Excuse me just a moment. All right, sorry about that, folks. So we start over again here. Let's start with our most popular and best-selling robot models. So right to my right here, I have our 4-axis 9484E. This is great for first-time buyers, right? Motorized head rotation, they're flexible. It offers approximately a 400 by 400 millimeter working area, approximately 14 inches square. Great price point and ROIs, and there are a variety of configurations available for these types of systems. So again, pictured here on the presentation and also to my right is our most popular and best-selling system to date. Now, a quick up-and-comer in the best-selling and most popular world is the machine just to its immediate right. And this is going to be our 5-axis dual alternating slide tabletop system. So again, very similar, great for first-time buyers, flexible, great price point and ROI, and it allows for progressive indexing of product. Now, I should note a few things about this machine. We've got configured here with an HMI touchscreen, which we'll touch on, again, no pun intended, we'll touch on that a little bit later in today's presentation. But what we're finding most popular is that clients have found that if their product resides in approximately, let's call it an 8 by 10 inch area on each slide, and 90% of their production was within that realm, a dual slide is a great fit. However, if we're considerate of maybe a 10% outlier product that's a little bit larger, some clients of ours have found that by simply removing the solder tip cleaning station, they can actually utilize the greater working area of that bed. So flexible enough to meet quite the needs of a variety of clients, but also that benefit on the dual alternating slide is to actually tie down to one slide and use a greater working area. And then lastly, on our best selling, most popular models is our 4-axis cantilever work cell. So this is great for contract manufacturers, NPI divisions, or soldering labs, right? So we have one configured here with a 4-zone bottom side IR preheat bed. They offer outstanding flexibility, right? There's no weight considerations for them. They have, the working area that's required, so they're ideal for high changeover. So again, very, very popular in the robotic soldering realm. And now let's turn the page to peripheral robot technology. So we know that robotics are very high precision. Matter of fact, all the robots here maintain a plus-minus positional tolerance of 0.02 millimeters, or 2/100ths of a millimeter, right? So they're extremely accurate. However, we know that in the soldering process, it's a degradative process, right? Our solder tips wear over time. So how do we accommodate for a degradative process like soldering in a high precision soldering robot? Well, we utilize what we call solder tip correction. So solder tip correction actually can be set up prior to creating your program that takes a measurement of your solder tip. And as your solder tip wears over time, we can run back to that station and actually take a measurement of the z-axis or the tip degradation and automatically overwrite and offset your program on the fly. Now, these solutions do consume working space of your robot. So what I will do through our peripheral robot technology is I'll also outline perhaps options and add-ons to be considered at time of order versus solutions or options and goodies that can be added on anytime after order. So because this solution works with the positional tolerance of the robot, it is best to consider this option at time of order, as they're really not friendly to integrate post-order. Now, again, generally speaking, these solutions are going to be used when the highest precision is required and for clients really looking to maximize the utilization of each and every solder tip. Now, I will point out as well as a disclaimer, all of our robots will feature the ability to select or group select your points, and you can manually, look at where your tip is and lower, and then you exchange the tip, put a new tip on, and raise it back up. Solder tip corrections devices, are doing that in a rather more automated fashion. So I just want to point that out. And becoming increasingly popular are solder wire preheat kits. So solder wire preheat kits are designed to nominally heat up the solder wire prior to introduction to the tip. Now this can reduce impact resistance and wear on the solder tip, and the best results are seen when the alloy is very hard, right? Now, we spoke a little bit earlier about the solder spool inside diameter and how do we deal with kinks, right? And on the flip side, if you're using like a eutectic tin lead, it's a very soft material. And so as you actually unspool that, very often we see these kinks. Now, if you think about a solder feeder being like a funnel where we're gathering material and bringing it down to a very high precision fine point, the closer we get to that output point, the more accurate we want to be. So we don't want any hiccups in the feeding process. So solder wire preheat kits can also take out kinks commonly seen in eutectic tin lead. And again, great solution for maximizing solder tip life. So again, they're generally going to be used when we're looking to maximize process stability, and most commonly in lead-free applications, because clients are always looking, if they're soldering at a higher temperature, they're also looking to improve solder tip life. Now, these solutions can be added on at any time. So I often encourage clients, if you're interested in exploring it, in lieu of some of your other options, let's take care of all the things at time of order first, and just know that this can be added on to any existing robot that you may have out there. So let's turn to heated nitrogen output kits. So first off, oxygen is a great gas, right? We live it, we breathe it, but the reality is it's also solely and single-handedly responsible for the oxidization of components and materials. So we spoke about flux being a oxidization remover. So what does nitrogen do for the process, right? Nitrogen, and we'll get on this in the next slide, the key word here is nitrogen in your process will actually displace the surrounding oxygen, right? And the purpose in doing that is actually to allow your solder flux to perform better. So nitrogen is an inert gas, meaning it's non-reactive, and it allows your flux to perform better and get that bonding process really, really stable. So heated nitrogen output kits, needless to say, are becoming increasingly popular, specific in the lead-free world. Heated nitrogen output kits will generate nitrogen at a 99.9% purity that will create a localized nitrogen stream surrounding and protecting the solder tip. Now, there are a variety of different output sleeves available, ranging from a greater spread, but if you have some components nearby that you don't want to reflow because it is coming out hot, we may elect for a smaller spread and a higher concentration. There are some other benefits as well, such as shinier lead-free joints, and also we can get a subsequential preheat or a convectional preheat effect. So if you look at this drawing here, we have kind of a row of pins. Well, as I'm driving heat to my board, as I spread heat and nitrogen across it, the next pins I'm going to solder will in fact already have some heat there. So there could be an additional benefit. Now, I'd also like to mention as I go into this next slide here that the nitrogen is a spread. So if you have temperature sensitive components or insulation jackets or dielectric Teflon inserts, just be aware that the nitrogen is coming out rather hot. So we don't want any melt back to surrounding components or landscape. So again, key benefits of nitrogen will be displacing the surrounding oxygen, and this is really a great, great show of detail here. It's hot, it allows the flux to perform its job better due to the displacement of oxygen, and it has a potential for preheat effect on subsequent locations. Now, we spoke about oxygen and the parental substrates, but let's not forget about the solder tip, right? In its idle state, the tip can also be oxidizing. So we can improve solder tip life as well by having nitrogen on in an idle state with the robot. And ultimately, nitrogen will add and increase process stability and lead to shinier lead-free joints. Interestingly enough, our Panda system actually has an N2 tip saver mode. So if someone's working with the robot and decides to walk away, needs to use the restroom, or there's a break coming up, they can actually click a button on the screen and we'll actually pump nitrogen and shroud the solder tip, protecting it from further degradation throughout the day. And now let's look at end effector fume extraction kits, right? Soldering does create hazardous and toxic fumes. These fumes are hazardous to human health and must be removed. So all of the robots here that PROMATION offers include end effector fume extraction kits, which create a localized plumbing of fumes created during the soldering process to be safely and effectively removed. Now, we also include overall work cell plumbing ports on top of the machine for additional extraction, but we just want to make sure that your end effector fume extraction kit is mated with a high-powered HEPA filtration system. Now, all of our robots, again, will come integrated with end effector fume extraction. If you have internal fume extraction, you can link them up. Otherwise, we also offer fume extraction stations that are standalone, which do a really great job. On that note, I'm just going to take one pop back. On the nitrogen side, all of our robots also come nitrogen ready, okay, meaning that every soldering iron has the ability to pump nitrogen through it. It's standard. So the only question you have to ask yourself is, do I have nitrogen generator on site? If I'm ordering tanks, do I want a tabletop N2 generator? So these are just really the options to be considered. Your robot will come N2 ready. You'll get the sleeves, you'll get the soldering iron, but how do we want to supply the nitrogen? If you have a generator, you can siphon off of it, or you can purchase a generator from us. All right. Now let's jump into HD camera kits, probably our most popular and best-selling add-on. Matter of fact, I think they're nearly standard with every robot we sell. Now, these aren't vision cameras, right? What the HD camera kits are designed to do is really just magnify the soldering process to an HD display. Now, this allows you to program from a safe distance. So if your eyesight is maybe not what it once was, you can actually look up at the screen and drive the robot to its location and just verify your positioning. Last but not least, I think it adds a bit of a showpiece to the equipment as well. If you're a contract manufacturer or even an OEM and you're entertaining clients walking through your facility, it certainly is kind of a statement piece that you can gather around and watch the process, right? So a very, very popular option for those reasons. And they are sold with nearly every soldering robot we offer. Can be added on at any time. So let's look at solder tip cleaning stations, right? Because they're also included with every robot that we offer. There are a variety of different cleaning stations available. I'll let you decide ultimately what's best. We have a dual rotating brass brush cleaning station, a dual rotating wet sponge cleaning station, and most standard is going to be our compressed air or compressed N2. So let's start with the compressed air because it's a non-contact means for cleaning the tip, meaning that it can promote longer solder tip life, right? But in some instances, we may be working with some nasty materials that actually generate more particulate on the tip, and so perhaps a contact cleaning method might be better serving our needs. So what I would arguably say is our most effective and certainly our most popular cleaning solution is our dual rotating brass brush cleaning station. While it is more aggressive because we're making contact with the tip, it is our preferred contact cleaning method for a variety of reasons. Now, traditionally, we sell about 9-to-1 of the brass brush over the wet sponge. So let's take a look at wet sponge because a dual rotating wet sponge offers a very effective clean, but there are just some considerations to be evaluated when making your decision on what's going to fit my needs best. Water is a great solvent, right? It offers an effective clean, but I also put in parentheses here, when used properly, right? And what I mean by this is that if you've ever gone out, let's say in the middle of summer and taken water from a water fountain or your hose and you throw it on the concrete, right? You come back in a few minutes and all of a sudden you see this white mineral silica on the ground. These are contaminants, right? So if we're using water from an unpure source or a water fountain, we just want to be aware that we could be introducing more or new contaminants to the process. So if you are going to be using a water for your rotating wet sponges, you want to make sure that you're using a distilled or DI water, right? That's number one. Number two, make sure it's not coming from a cooled water fountain. We obviously don't want to thermally shock the tip because as we, understand the physics of materials, they expand and contract, right? So we don't want to use cold water where we're thermally shocking the tip or there's a ramp up rate of temperature that needs to happen after the cleaning cycle. So again, just some things to consider. And then last but not least, does your manufacturing operation allow water near the factory floor? Sometimes this is a big no-no. Other people may not have an issue with it. So just something to be considerate of. We also have some solutions, which you'll see today, that actually include a combination of cleaning, right? So on our new M-Series robot, for example, we have a compressed nitrogen cleaning station and a dual rotating brass brush. And this allows the flexibility for our clients to utilize a non-contact cleaning method more frequently. And then when they do get a buildup, they can actually jump over to a contact method cleaning to get some of those harder to remove contaminants off. Now let's touch on the HMI touchscreen option. So we kind of spoke about some of our most popular and best-selling systems utilizing HMI touchscreens. Now these are becoming very, very popular as of last year, right, into this year. And I'm happy to share why now and also at the end of our presentation here. So a human-machine interface actually removes the editing capability from the operator. So these are password protected. There are 3 levels of accessibility. And if you're worried about any of your programs being perhaps modified without your knowledge, an HMI touchscreen is a great option just for selecting programs and allowing the operator to utilize an interface with this touchscreen to run day-to-day operations, right? They can't modify, they can't change a program. They simply make the product fixture with the program list on the HMI and press go. Now I'll also just kind of give a plug here, which we'll talk about in the later portion. We're also featuring now what we're looking at as cobot-ready relationships. So we'll touch on that a little bit more on the back end of today's discussion. So a little bit more that meets the eye in terms of our planning for the future. So we'll talk about preheat. Preheat's ideal for thermally challenging applications. There are really two main types of preheat, right? We have an IR or an infrared and a convectional. So convectional, forgive me for being trivial, is much like your oven at home that you bake cookies in, right? It's a hot air. So IR preheat, some pros of it is that it's a fast heating technology and it offers a rather stable heating. The cons, however, is that it's reflective. So we've gotten applications where LEDs drive a lot of heat when they're in use. So they're typically mounted to aluminum, kind of looks like a license plate in some in cases. And that material or aluminum can be very reflective. So aluminum is one of those materials that in some cases can dissipate heat just about as fast as we try to put it in there with an IR preheater. So in this case, we might be looking at something more like convectional preheat. Now, convectional preheat can be offered in a contact and non-contact solution. So the pros of a convectional preheat is that it's non-reflective and extremely stable. The cons, however, is that it is a slightly slower heating cycle, and typically the materials, if you think about it because they have more mass, are going to be staying hotter longer. So something to be considered. Now in this solution here, we have an IR preheater, kind of looking at a suspended type where the product is hanging over the preheater. And then in this solution, we have a convectional heat utilized through a hot plate, right? So the bottom of the board may be in contact with a heated element, and we're driving heat through a convectional method. Now again, there are different methods for application of preheat. Again, the non-contact or suspended method, which is like what we have here in our new M-Series CJ system, least aggressive, safe, cost-effective, and certainly flexible, right? Our contact method, by contrast, such as a hot plate, might have a fixed area, so a little bit less flexible, and keep in mind it's going to be stay hotter longer, right? So just be aware that safety can vary when interfacing with some of these. Now, I have some of these photos here because I thought they were really interesting. We came across an application for one of our clients that utilized a plastic housing, and they had a problem getting barrel fill, right? So what's going on is they have a plastic housing with metal pins, molded into the plastic housing, and then they put a board on top. And when they're going to solder that board, they were struggling getting barrel fill, right? So how do we drive heat? Well, we can provide a bottom, solder always migrates towards the heat source, right? So we can apply preheat, but we can't use a traditional preheater or an IR preheater because we melt the plastic, right? So what do we do? Well, interestingly enough, what we did is we designed these product fixtures with metal pins in them. So when they loaded the plastic housing, these metal pins were in contact with the metal pins in the plastic housing, meaning that we're providing a direct convectional preheat to the bottom of the housing. Then the board is loaded in, and we cycle the robot, and it runs and solders the parts. Now, what's really unique about this is we actually used our solder wire preheat kits. So knowing that applications can sometimes dissipate heat differently throughout the board, each individual pin was monitored independently by having its own preheat channel. So a pretty unique application I figured we'd throw out there. And then finally, let's look at dynamic vision alignment technology, right? So dynamic vision alignment solutions allow the robot to automatically offset based upon part-to-part discrepancies. Most standard vision alignment systems will utilize what we call models for reference, right? And ideal applications where soldering locations ideal applications for vision might be soldering applications where the locations are located on a board-on-board application, right? Where we can locate the outer frame, but maybe that doesn't tell us exactly where the board is consistently on top of the other. Also, plastic housing is a great example. There obviously can be some tolerance shift. So although we can pocket and cavity a product fixture to hold the housing, that may not tell us any real location of where the board is within. So again, two great candidates that might be an initial knee-jerk is to say, oh, I need dynamic vision for my application. Now, we'll also be transparent here that dynamic vision and how much you're using of it does take and consume cycle time, right? So just be considerate if you're really looking at vision and also press for cycle time. The more vision you add and the more capability can also increase cycle time. And certainly this is going to be one of those options that's best integrated at time of order because, again, it's working with the robot's positional tolerance. Now, there are different versions of dynamic vision alignment systems available. They do range in capability and technology. So most vision systems out there will include a cutoff score or a match score, right? This will allow the user to define acceptable and unacceptable visual results, right? If my vision system says, hey, I have to move 5 millimeters, one might consider, hey, I have a problem somewhere else in my process if I'm getting that much shift, right? So it always depends on the application, but most of them will allow you some sort of grading or cutoff score. Some vision systems can also calculate what we call a size error. So this can be a method used through the camera to actually control the z-axis. And the size error would mean if my product is maybe not loaded all the way and it's closer to the camera, well, it's appearing X amount of percentage larger. If it's further away, it may be X amount of percentage smaller. So again, maybe something to explore when you're looking. And just another note here, vision systems do need to be calibrated from the factory or on site. Most vision systems have a camera mount point and then your soldering iron, right? So we need to be able to tell the robot what that spacing is. And if you change your angle in some cases or the length of your tip, it may need to be recalibrated. So something to at least consider. So now let's touch on the robot selection process. After all that, we say, okay, you know, I'm interested, right? What do I have to consider? And so these are questions that I've defined that I really often ask clients to really best guide my search. And if you ask yourself these questions and jot down your answers, it might really elevate your conversations with a supplier. So first off, you know, what is the max board size that I plan on running, right? Because ultimately that will define what robot size you need. Are there any weight considerations? You know, what's the heaviest board I'm going to be running or application? And then also, what's the max application height? You know, if I have tall products or things that I need to hop over, are there any customization features that need to hop into an off-the-shelf solution? Do I have any thermally challenging ground planes, right? This is something that I always ask on every application sheet that we send out because, you know, in order to facilitate a quality soldering program, I have to be transparent with clients about what the challenges are, right? Is there a most common solder wire alloy and type and diameter that you're using, right? If you're running a variety of products, but you're really mated in with two diameters or a single diameter, perhaps there are some optimization feeders on the solder feeder we can consider. And ultimately ask yourself, you know, what is the expected quality and throughput requirement of the automated system? Now, this kind of goes back to the study we did in Wisconsin. Although there may be some rework, you know, am I making more parts? Does that part count exceed what I can do manually? So is there still a benefit there? And ultimately, how far do I want to go down and make sure that I'm maintaining my optimization factor? Are there any floor space constraints? You know, it's good to be upfront too, because if floor space, if you have a brick and mortar issue, you know, your supplier can certainly kind of design enclosures and things around those constraints. Again, perfect lead in, do I require a safety enclosure, right? So kind of going hand in hand here. What are the safety requirements by my factory? You know, can we get away with a robot model without one? Based upon what robot model I need, does it facilitate a safety enclosure? And do I have fixturing resources or a local tooling shop or an on-site machine shop, right? Please note that product fixtures go hand in hand with the type of robot we choose, with the type of process we have, the ease of loading that process, right? So very, very critical, and I often recommend if you have an on-site machine shop or a local tooling shop, that will be a great, great resource for you. And then lastly, you know, what are my goals for robotic soldering and what is my budget, right? It's safe to say that there are endless opportunities with providing more and more and furthering autonomy with robots. But, you know, what is the realistic budget, right? And that might help hone in, okay, the nice to have or the wish list items versus the non-negotiables, right? So just an honest conversation to ask yourself. Now, within this robot selection process, most companies will offer what we call a proof of concept or risk mitigation assessment. Matter of fact, I've done this with quite a few of you here in person. And so what this is, in short, is candidates can submit samples or ideal applications for robotic soldering to be loaded onto a robot and have the robot's capabilities demonstrated. HD video, you know, can be provided either through the onboard camera or through another HD camera source and provided back to the client for evaluation, right? And this kind of shows, can we get in there? Can we get the soldering quality we're looking for? And the benefit is really twofold, right? On one hand, you're going to see the robot's capabilities, And for us as suppliers, we're allowed to know that regardless of which robot you choose, we now know the soldering iron, the wattage, the tip size, the ideal feeder for your application. And so all of this helps us kind of custom tailor the package to your specific needs. Now, I get asked this all the time. What's my solder tip life going to be? A very, very popular question, and albeit fair, right? But the truth is, no one can tell you what your solder tip life is going to be. I may only see 10 to 12 parts. That is not going to be indicative of the 30,000 parts you're going to run at your facility, right? Am I using nitrogen? What type of solder tip cleaning am I using? How frequently am I using my solder tip cleaning? What sort of temperature am I soldering at? All of these things, right, can affect the longevity of a solder tip. Now, there are some perfect world numbers that I'm happy to share. In general terms, our industrial grade high performance solder tips will range from about 32,000 shots to about 75,000. We have some clients that may get only a handful of joints, from their tip because their process is so acidic and degradative, right? So, we can give you real world numbers, but just know that, to speculate would be inaccurate, right? Ultimately, you'll have a good idea when you start getting into production 30 to 60 days, and then be able to better regiment your cost of ownership over the process. So I always highly encourage companies to participate in the mitigation of risk and prove process stability, as again, both sides benefit, right? So let's touch on for a moment product fixturing and tooling. Product fixtures and tooling are critical to the robot's success rate. It is always recommended and best to work with someone local to reduce lead time and turnaround. Now, again, if you have a machine shop on site or a tooling or a CNC shop down the street, these are going to be great resources for you because, fixtures can take a few times to get just right. Is the operator happy loading them? Am I happy with how it's holding the part? So don't be discouraged if the fixture is not perfect right out the gate. It can take a few times. But some key features that product fixtures should be easily loaded and unloaded, right? And we don't want to limit the robot's ability to get into and access to and from the soldering area. So simple and accurate loading of parts is key. We don't want to limit the robot's ability to get into the joint. And there are materials out there that are ideal for product fixtures. Durastone, for example, which most of us probably know as a wave solder pallet material, is great because it's heat dissipative. Bakelite is another one, and there certainly may be others. I just encourage clients when I walk in and I see an aluminum fixture in contact with the board, don't allow your product fixture to also thermally ground your board, right? Otherwise, we'll sit there going, well, my hand solderer can do it in 2 seconds. We probably could too if we weren't thermally grounded. So again, just something to consider here. So again, some important notes on the product fixturing and tooling roundup. Robot selection and product fixturing do go hand in hand. And a great example of this is, while it's ideal to stuff as many parts into the robot working area as possible, if the load time, we'll take stranded wires, for example, right? Copper stranded wires are going to accept heat very quickly. Generally speaking, they solder very quickly. But wires are also a finicky thing to have to maneuver and into a product fixture. So while our idea is to shove as many parts into the robot as possible, let's be realistic. If my product fixture, just due to the nature of the process, takes 5 to 10 minutes to load, and my process only takes 2 minutes to solder them, well, we have a very unbalanced process, right? So we might look at our system and say, you know what, a dual slide works great. Instead of processing 5 or 10 at a time, maybe I do 1 or 2. Also, this advice is somewhat inconsiderate of how your parts are flowing to you, right? So also look at how parts are going to feed the cell and how they're going to be taken away. Do I have batches of products prepared for me from last night, or am I getting one off at the line at a time? And ultimately, that can help decide how we want to structure the product fixture and your robot. So again, consider the cycle time to load and unload to ensure a balanced process. Maximize parts fitted in the machine when possible, but don't overload the machine so it's waiting on the operator. Again, to repeat, fixtures can take a few times and a few revisions to achieve something ideal in terms of balance and loading and unloading capability. Also, if you're in a high-mix application environment or a contract manufacturer, tooling can get expensive based upon the variety of products that you're doing. So I often consider, we've had some clients that, go out to product fixture companies and get estimates, and they build that into their bid, right, so that it's accounted for. In other instances, if you're an OEM who's going through a lot of board divisions, it might be best to wait for the final revision. So that way you're not incurring product fixturing expense all along the way. And if you are a high mix application environment, I definitely recommend and suggest you focus on high running or high value applications first, as that will be where your biggest value and bang for buck is, right? We're getting close to the end here, so that's the good news. Our philosophy, right? Let the applications drive the solution. As you can see in our facility here, I have a wide variety of robotic applications. I'm not locked into 3 or 5 different robot models and trying to shove a square peg in a round hole, and neither should you, right? Look at the options available and ultimately let the application decide what's going to be the best fit. It's always better to make quality parts than a high volume of defective parts, right? So you want to make sure that everything's balanced, you have the proper technology, so forth, so on. And if defects are seen at a high rate with your robot, remember that robots are repeatable. So any amount of inconsistency in your materials, your variables, such as your product fixture, right? Environment even. If you're in a warehouse with a sliding dock door, maybe you have to adjust your program from January to July, right? We could have very different results. So if you are seeing high defects, definitely look at those variables and try to get a better control plan. Although we're automating, the required time to properly form that intermetallic bond is not going to change drastically. So definitely explore scale-up options versus risky programming, right? If we're on that hairy edge of it kind of works and it generally doesn't, you're better to look with your supplier and say, what options do you have for me to scale up versus a program that's kind of producing subpar results, right? Standardization of end effector components is always highly desirable, but certainly not always possible. So again, these are rules to kind of guide you to say, when possible, try to do this. But if it doesn't make sense, don't try to force it, right? Some changeover ultimately may be required. So developing an action plan or a PM list prior to production, right? And this goes into calibrating temperatures, verifying your materials are not expired, and some of these other things. And as I always default to, planned prevention is significantly less costly than unplanned intervention, right? So if I have to go to the robot and something's going wrong, I'm starting to just lose parts and lose value in the process. So try to create a good planned prevention. So what do we offer, right? Well, PROMATION offers, of course, the proof of concept risk mitigation assessment. Now, this is not only for newcomers to PROMATION, right? Some of you here have been clients of PROMATION for a very long time. So as new applications come up, if you need to step back and get help in recipe building, feel free to send us your applications. It only helps hone my team's skills, right, and make us better, and ultimately it's a benefit to you. So we always make that available for our clients, new and existing. We offer cycle time analysis, right? So as part of that proof of concept service we offer, we'll know the cycle times that we're producing, right? And a required technology package. Now we also provide a nice HD process video, and we do application testing, review, and consulting. So the moment we've all been waiting for, right? What's on the horizon? I've been really pushing our team to not just reintroduce and reskin what's been out there, right? We really want to push the level of innovation. And so I'm delighted to share with you some of the next gen technology that PROMATION is working on right now. So I always say that companies can become comfortable, right? Reducing their ability to push innovation in a trade-off for what works well today. My belief is that companies who don't innovate and often inconvenience themselves simply do not continue to exist, right? Lack of innovation in my world is a disservice to all of you, my clients, and innovation is truly me providing a service in addition to the product and the support itself, right? So we really weigh heavily, and I love this photo. It was Halloween, and we just want to remind everyone that our solutions are out of this world, right? So that's fun. Gotta have fun. So on the horizon, right, is my application too small for traditional robotic soldering? You know, people come to us for solutions. So if robotic soldering isn't doing it, just because we can't do it doesn't mean the problem goes away, right? It's still there. So we've actually got a lucrative up and coming solution called our dispense and reflow, right? And the idea is that when I can't fit a solder wire adjustment angled kit in there, or something's kind of buried in there, how am I going to process it, right? So our dispense and reflow solutions are actually great for fine pitch or tight tolerance applications where solder wire feeding simply does not make sense anymore. So we utilize a solder paste dispensing robot and provide a localized, right, a very finite nozzle of heated nitrogen to actually reflow the solder paste. So this can be a great solution when, again, traditional robotic soldering does not make sense or things get too tiny on the micro scale. Again, as you look around and walk around this afternoon and even this morning, you'll notice that many of our robots have HMI touchscreens. So we spoke about the benefits of an HMI touchscreen in terms of limiting operator intervention on the day-to-day production run. But there's also kind of a lateral move we're making, right? And that's with the introduction of cobots, right? So PROMATION is an exclusive integrator and distributor for Techman collaborative robots. These are vision-guided collaborative robots. And because they have vision out of the box, we're able to do quite a variety of unique things. We can scan barcodes. We have what we call OCR, or optical character recognition. We have color detection, identify and measure tools, right? So our HMI touchscreens that are being outfitted on our industrial robots, which are fast, right, actually offer a long-term scalable approach for our clients. So, you know, we focus on today's task, right? Let's automate the soldering process. Let's automate the screw driving process. But down the road, we want to maybe consider further autonomy. So what we're doing is we're configuring the robot today for the needs of tomorrow, right? So when you purchase a machine that's configured with an HMI touchscreen, you can come back 3 days, 3 months, or 3 years later and add on a vision-guided cobot. We've got some great examples of an autonomous machine attendant here. So one of our robots is configured with an HMI touchscreen. We can scan barcodes, scan product information, select the program, and then we're looking at a light tower, right? There's no electrical tether. So we can be monitoring the color of the light tower, and then when it goes green, we actually go and tend to the solution and send the product down line. So some great capability and a very easy upgrade option to add some flexibility for the future. Again, a perfect lead in here to our all-new M-Series soldering system. You know, we spoke a lot about the technology, the powerful soldering tools we have, the available options, and through this list, when we go down and look at dynamic vision alignment with model matching, a powerful 180-watt power supply, an under head mount solder feeder mated with the HMI touchscreen upgrade, a nice camera kit, heated nitrogen output kit with onboard N2 generator, integrated solder tip correction, upgraded solder tip cleaning station with our brass brush, integrated Keyence light curtain, and our tempered glass safety closure option. It is a very well outfitted machine, right? So we're delighted to share that with you, and we have a few other versions of the M-Series here as well that feature the dynamic vision model mapping. So delighted to share that, and you'll see more in the coming weeks on the marketing of this new technology. And then, of course, I'd be remiss if I didn't show you the sports car, right? The high-performance vehicle. So I'm delighted, of course, to introduce or reintroduce some of you to the 3-time technology award-winning Panda intelligent robotic soldering system. The Panda is a state-of-the-art machine because it utilizes a dynamic vision alignment with model mapping, right? So it's actually configured with a touchscreen PC. We have a dual monitor mode. So actually, as I load a board, I'm able to take a vision map and stitch it together. And as I click on that vision map, my robot actually has the ability to pick up and drive to the locations in which I'm interacting with on the screen. Now, because it's PC-based, we also have the ability to do remote login. We can generate process data. So if you're a client or a company looking to for process data, you know, I want to know who is soldering product on May 3rd at 9:44 in the morning, right? The Panda machine will be able to deliver that sort of data traceability for you. It's got some really nice features as well, such as a dual articulating soldering end effector, which allows the soldering iron and the feeder to independently piston in and out of one another. This can be great for faster cycle time or allowing us to dive deeper into a solder tip cleaning station. So again, mated with a very powerful vision system, it's very, very capable in delivering some truly powerful soldering results. Now we have some upgraded solder tip cleaning on here as well. And I'd also like to point out that while it's well configured with onboard nitrogen and some upgraded tip cleaning technologies, we also have an available option, which is what we call our optional barcode scanner. So our optional barcode scanner is utilized on an in-feed conveyor, and that ultimately can scan a barcode and auto-select a program from the machine. So if you're running a variety of different products, the ability to buffer boards in front and have the machine do the work is a great solution to further remove the human. And then lastly, because it's PC-based, we can do remote login sections, and with our augmented reality, a wearable session. So we've been working with Epson Movero Glass. We have migrated to Google Glass, and certainly it will be interesting to see what wearable tech comes out in the near future. But it's a great service to our clients to be able to, we understand that soldering can just require a trained eye, right? You really have to know the process and what's going on. So allowing us to look at the log files the machine is generating, look through the vision camera, and with wearable tech, we can provide prompts to the operator, and we can service clients on the East Coast, the West Coast, in Europe, and in Mexico, all in the same afternoon with no additional overhead from the client themselves, right? So access to immediate support and service, we feel is a great service to our clients as well. Now, of course, because it's inline, there are a variety of different configurations we can add to the machine, but we'd like to kind of demonstrate the high capacity aspect of this machine. While the most common configuration is a standard in-feed conveyor where I'm prepping parts, I run it through the machine, unload them, we also don't want to forget that PROMATION's bread and butter for over 25 years has been premium material handling solutions, right? So we have the ability to create a high capacity rack buffer system where at the end of the night, you can prepare boards for tomorrow morning's run, we'll buffer them into a rack, right? And literally completely walk away from the machine for an hour or two and let it select and provide that soldering process, and then rebuffer product on the outfeed side. When that rack buffer is full, it will alarm saying, hey, someone come tend me. So a really great solution, and of course a scalable approach, right? You're able to manually load today, and if you want to add more and more capacity, that will be coming in the near future as well. I also should point out that PROMATION is also a certified integrator for Omron AMRs. These are the autonomous mobile robots. Probably seen them carting around a trade show and on the factory floor. By the end of July, I'll actually have a full system here with fleet management. So PROMATION has gone out, we've designed and engineered and built, I think they're in transit to us right now, magazine line loading solutions. So this will be a great time to come back and review PROMATION's intelligent line control solution, where we can manage deployment through a call box button. An operator can select what products they need. The mobile robot will go select them from a storage tower and then dock with your SMT line or your Panda line and actually introduce parts, and then it can go to the back end and take away parts, right? So we're in a world of autonomous fulfillment, and we're continuing to push on that topic. Now, of course, I'm delighted to introduce some of you. I think I've had this conversation for already, but for those tuning in virtually, I'm of course very excited to introduce the next giant leap for the Panda robotic soldering cell. I've taken the innovation very seriously of this machine, and when we set out to design this machine, I had a vision that I wanted to push into the next generation, really push the boundaries of what machines and humans are doing today and what they'll be doing tomorrow. So I'm delighted to introduce that as of this summer, we will be introducing a new adaptive IQ to the Panda system. So our Panda system is already touchscreen interfaced. We will be actually introducing a see-through transparent touchscreen OLED by LG into the surface of this machine. So all of the software is done. My theory was to actually take out the front of the machine or the panoramic roof and integrate a touchscreen see-through OLED. So much like Avatar, you can walk up to the machine and just start touching the surface and programming it, right? So for those of you who really view your process as a showpiece, we want to change the way that we're growing and learning and adapting with our robotic solutions. Now, off to my left here, we actually have the transparent touchscreen OLED already here. Back behind me, which you can't see, is our retrofitted door. So while I would have loved to have it here today, again, as I said earlier, I don't want to rush things, right? They need to be right. But this is our next giant leap. And what I like to kind of say is when we look at the Panda machine, we've done some really unique things with the design of it. We have an extremely flat front surface of it. We have a nice lower, ground effects kit, if you will, that actually allows it to look like it's been erected out of the floor. In the corners, it actually took us about 3 months to manufacture the rounded edges. So when we start talking about integrating a transparent OLED into it, and you look at the rounded edges and the front of the machine, it actually really begins to look like an iPhone, right? Something that we carry around and interact with every day of our lives. So I really want to bring that sentiment to the robotic soldering realm and to PROMATION. Now, I'll also say this as a teaser. We've done some testing with the OG LED, and there will be a trickle down to some of the other products that we're offering. So stay tuned with us. We have some really, really incredible technology on the roadmap. And again, I can't thank you enough for being a part of this momentous day here at PROMATION USA. I hope you'll trust us as your official all things robotic soldering supplier in the near future. And thank you again. So what I'd like to do now is if there are any, we're going to open to a Q&A.